Acids generally contain hydrogen on the left side of their chemical formula. The thing that makes them an acid is that they can lose H+ ions into solution. We will be dividing acids into two categories, simple binary acids and oxyacids. Simple binary acids have hydrogen plus one other type of nonmetal. There could be multiple hydrogens to balance out the charge on the nonmetal, but it's just two types of elements total. Some examples are HCl, which just has hydrogen and chlorine, HBr, which just has hydrogen and bromine, and H2S, which has just hydrogen and sulfur. We are also going to treat HCN like a simple binary acid, even though it contains hydrogen plus two different elements. The cyanide ion acts similarly to halide ions, such as chloride. It is small and has a -1 charge. The cyanide ion does not contain oxygen. Because of those things, HCN gets named as a simple binary acid. The other category of acids is the oxyacids. As the name suggests, oxyacids contain oxygen. They all contain hydrogen on the left, plus an oxyanion on the right. In other words, they will have some number of hydrogens, then a nonmetal, then some number of oxygens. Some examples include HNO3, which is hydrogen with nitrate, H2CO3, which is hydrogens with carbonate, and H3PO4, which is hydrogens with phosphate. All of the simple binary acids have the following naming convention: hydro-something-ic acid. The something will be the base name of the nonmetal. For example, the simple acid that contains hydrogen and chlorine is hydrochloric acid. The simple acid that contains hydrogen and fluorine is hydrofluoric acid. The simple acid that contains hydrogen and cyanide is hydrocyanic acid. The simple acid that contains hydrogen and sulfur is hydrosulfuric acid. Notice there are two hydrogens with the sulfur. Since sulfur is in group 6A, it has a -2 charge as an ion, so 2 + 1 hydrogens would be needed to make a neutral acid. One thing to note is that for our simple acids, to write the formula properly, you have to include the AQ symbol, which means that it is dissolved in water. In order for it to work like an acid and release its hydrogen ion, it must be dissolved in water. The AQ symbol may be included with the oxyacids as well, but it is only the simple acids where including it is absolutely necessary. Since both simple acids and oxyacids might have the AQ symbol next to them, you cannot rely on the presence of the AQ symbol to tell you which of the two categories of acids to name it as. Instead, you will be looking for the hydro part of the name. Only the simple binary acids have hydro in the front of their name. The oxyacids do not. What is the name of H3N aqueous? Is it A, nitric acid, B, hydronitric acid, C, hydrogen nitride, or D, nitrous acid? The correct answer is B, hydronitric acid. We see that it has hydrogen plus only one other element, and it has the AQ symbol, so we are naming it like a simple binary acid. It will be hydro-something-ic acid. Since the nonmetal that is with the hydrogen is nitrogen, the acid must be hydronitric acid. I've mentioned that for the simple binary acids, we must include the AQ symbol if we are writing the formula. If the formula does not include the AQ symbol, it would be named similarly to a simple binary ionic compound. We would list the first element, hydrogen. Then we would list the second element with the IDE ending. For example, HCl with no AQ symbol would be hydrogen chloride. HF with no AQ symbol would be hydrogen fluoride. HCN with no AQ symbol would be hydrogen cyanide. H2S with no AQ symbol would be hydrogen sulfide. This poll question looks very similar to the previous one, but it is not quite the same. What is the name of H3N? Is it A, nitric acid, B, hydronitric acid, C, hydrogen nitride, or D, nitrous acid? The correct answer is C, hydrogen nitride. Since there is no AQ symbol, but it still otherwise looks like a simple acid, we name it similarly to a simple binary ionic compound. We list hydrogen and then the nonmetal with the IDE ending. In this case, it becomes hydrogen nitride. Pay close attention. For the oxyacids, you will name it the same way whether it has the AQ symbol or not. It is only the simple acids where the AQ symbol makes a difference. Going from the name to the formula, you're going to be looking for that hydro in the front. Anything with the general name hydro something-ic acid is a simple acid. That means it only has hydrogen and one other nonmetal, with the exception of hydrocyanic acid. Once we have identified that it must be a simple binary acid, we need to identify which nonmetal is paired with the hydrogen. That will be based on whatever is filling in the blank. Let's say we had the name hydroselenic acid. The base nonmetal must be selenium, so the hydrogen or hydrogens would be paired with the selenide ion. We need to know how many hydrogens to put with it, so we need to know the charge on the selenide ion. Since selenium is in group 6A, it must have a -2 charge. We need to add enough +1 hydrogens to make a neutral acid. If you want, you can use the crisscross rule with the H+ ion and the anion. If we were doing the crisscross here, the +1 from the hydrogen would be the subscript on the selenium, and the -2 on the selenium would go down as a subscript of 2 on the hydrogen. That would give us the formula of H2Se. Since it is a simple binary acid, we must include the AQ symbol. Otherwise, someone going from our formula to the name would call it hydrogen selenide instead of hydroselenic acid. What is the formula of hydrosulfuric acid? Is it A, H2SO4 aqueous, B, H2SO3 aqueous, C, HS aqueous, or D, H2S aqueous? The correct answer is D, H2S aqueous. Since it has the naming format hydro something-ic acid, it must be a simple binary acid. The something in this case is sulfur, so our compound must have hydrogen and sulfur. The hydrogen is a +1 ion and the sulfur is a -2 ion. So when we crisscross, we get H2S. Again, don't forget the aqueous symbol, especially for the simple binary acids. For future reference, A, H2SO4, would be sulfuric acid, not hydrosulfuric acid. B, H2SO3, would be sulfurous acid. C does not exist because it would not be electronically neutral. Hydrogen ion is +1 and sulfide is -2.